All right, hello everyone. So as you just heard, we are Brian and Michael. So I'm Brian.
Hey Brian, I'm Michael.
Hey Michael. So we're really glad to be here to talk to you guys a little bit about edge computing. So you just heard about Edge Monsters, a group that Michael and I are both part of. And one of the really interesting things that we have observed over about 18 months of having really interesting conversations together about challenges at the edge, design considerations at the edge, different architecture approaches, is that the realities of making a really delicious, hot, wonderful chicken sandwich, hopefully making you hungry right now. Those challenges, doing that with high quality and great speed of service and a great service to our customer, are actually very interestingly similar to the challenges that exist in the Air Force. So we want to tell you a little bit about that today. But before we get too far ahead of ourselves, we probably should just ask the question, what's actually is the edge? Yeah.
Yeah, so let's talk about that for a second with a quick demo. Everybody's kind of done this. Well, you have to go to a site, and sure enough, you bring a giant Pelican case full of stuff. So the edge all depends on who you need to serve, how many people you need to serve, what you're serving, whether it's chicken sandwiches or warfighter lethality on the edge and a bunch of tents. You wind up dragging these 100-pound cases around. I have at least 250 people to serve in a tent, and so we need an edge that looks kind of like more like a fog node and delivers all sorts of legacy stuff along with some of the newer stuff. The Air Force isn't really 100% into Kubernetes yet, so they still really love their VMs. So we have this giant thing, right?
Well, actually, I disagree.
What's your edge?
This is the edge.
Oh, I see. Well, I mean, I got a Raspberry Pi 5. Everybody has a Raspberry Pi 5, at least I have about 20 of them. So there's an edge. What else? What other edge do you have?
I'm out.
You're out? Well, that Raspberry Pi 5 wasn't enough, so we need a ruggedized like MIL-10, A10G shock rated. It's sort of it's an edge controller, it's a router, yep.
What else you got?
That too. Oh, what else do I have? Well, no edge solution is complete without, giant bag of wires and tons of, and it's a router too, because we need routers. But does the router actually belong in here? I'm not sure. So we figured that out. And connectivity, right? So we got another one. We need a 5G capability here, 4G LTE capability, maybe LTE-M capability.
That's awesome.
Another thing, what else do I have? The real edge that we all carry around in our pocket.
Yeah, I got one of those too.
You got one of those?
Yeah. Well,
what else do you have?
Well, that's it. But I think we should talk about what the definition of the edge actually is. So we've got all these devices, but I think what makes the edge actually interesting is that edge is about bringing compute of many different shapes and sizes, correct ones or incorrect ones, to the problem, to the place where the action is. So let me tell you about, in my world, what that means. For us, the place where the action is restaurants. And so our journey into edge was actually driven by the fact that if you've been to Chick-fil-A, who's been to Chick-fil-A before? Most people? Yeah, woo, all right, awesome.
All right.
Thank you guys, keep coming. But our journey into edge was really driven by the fact that Chick-fil-A's are really busy, and we have really big capacity challenges in our restaurants, meaning it's really hard for the owner-operator of a store to keep growing the sales in that footprint, and we want to make that possible for them. So we went down this journey of edge to figure out how can we start bringing technology to bear in the challenges of our business, specifically around capacity, so that we could still cook and serve really great hot food, do it really fast in these really busy, crazy long drive-through lines, and still deliver ultimately this personal experience to people who want to be served by another person. And so that was the reason that we went into edge, and you see a picture here in the middle of kind of what our actual world looks like, which is these three little Intel Nooks that together are about the size of a Chick-fil-A sandwich, and also quite delicious. How about you, Michael? What about
well, the edge is quite different for us. So the edge, in general, we've always been on the edge. This is what the Air Force does. We deliver to our capabilities to remote and austere locations around the world, and we need to be able to do it like right away. We need to be able to pack it up, run, start it up, and get our network connectivity and our core services up and running at a moment's notice. And that includes new modern paradigms, being able to do content delivery whether it be a warfighter's email, yes, they still use email, unfortunately, and various other distributed command and control applications. So you see a smattering of experiments that I've been a part of, all the way from MilSatcom to autonomous systems, self-driving robots, and things like that you see in the lower left-hand corner, and then other stuff we can't really talk about, but you can think of it as distributed command and control for global forces that we present worldwide. You hear about that in the news. And a lot of that is done actually on the edge. So a lot of my development has been in the van, you see in the middle of the screen. That was a shot from an exercise I went to. It was like 2 a.m. I was still programming. Really, the edge is something that you have to understand and live in order to be able to deploy it.
Awesome. Well, one of the things that we think defines the edge, in addition to bringing the compute close to the problem, is some of the unique challenges of it. So we're going to tell you about 2 of those really quick. The first is that the edge has constraints that if you've grown up in the world of using the cloud, or if you're an AI engineer and you just started slinging code with coding tools in the last couple months, these are things that maybe you haven't necessarily had to deal with as much. But a couple of them are around connectivity. So connectivity is a challenge. You may have lots of solutions, like in Michael's case, that can help with that. But even in a restaurant where it's a fixed location, connectivity has always been a challenge for us. So whether it's up or down, like that can have an impact on the restaurant's operations. Certainly bandwidth, which we can get decent amounts, but still it's a constraint that we have to live with. Other ones could be resources like physical compute, and that for us is driven largely by the physical space constraint. So we can fit this in an office in one of our restaurants in the back, but we don't necessarily have room for 1 or 2 or 3 of these things to fit in our store. And so we've got to think about those physical space constraints as well. Another fun one is you don't really have tech support. So in my world, we've got team members who are serving customers and dropping fries and cooking chicken. In Michael's world, he's got a whole different set of people there. And then there's also, of course, the cost. So doing something in one location, you can spend some money. Do anything in maybe 10 locations, or you think about cloud, maybe being in like 10 different regions. You're spending a little bit more money. But when you start thinking about things that multiply by 3,000, 10,000, 100,000 footprints, it can get really, really expensive really fast. And so you've got to bring that into your thinking as you think about designing your architecture. How about the entire stack? Want to tell us about this?
Absolutely. So for us, we have to own the entire stack. We don't need to rely on anybody. We can't rely on anybody, so we need multiple modes of connectivity. We need to deal with hardware supply chain. Is this really my edge? Has it been modified? So we have some deep security concerns. So if you look at secure onboarding, how to be able to really deploy the edge such that we know what is running on this box, and there is absolutely nothing that's unintentional. Being able to push batches to this thing, because maybe our remote edge is unmanned and it is left, zip tied to a tree or some power pole or whatever, and it's been left because it's a relay station and it's an unmanned relay station. Cluster management is a huge deal. Being able to push the right configuration to our edge node and then have that be updated and live. Inventory management, fleet management for the edge nodes is a huge deal. I'm sure it is at Chick-fil-A as well. And so really, like, how do we do the edge piece is like this deep thing that we really need to understand. Next.
Awesome. So what we're going to do is try and share here in the next 10 minutes really fast 6 principles for you if you want to crush it at the edge. These are about scale, but these could apply if you want to build your own home lab when you get home. I hope you will. So Michael's going to kick us off with the first one. Take it away.
Absolutely. Do the differentiated heavy lifting. Nobody's going to do the work for you. These commercial turnkey solutions may be able to get you out of a bind in some regards, but you absolutely need to understand the tech stack, and you need to figure out your infrastructure and how that fan out can occur. And then how you really are going to deliver things. Like, what is your content delivery network? What are you putting on this edge node at first? How are you booting it? Is it too much? Are you trying to bring the entire internet and shove it in a little box because you're super comfortable with the cloud? So you go, you know what? I'm going to try to put every service I've ever used on this thing. Oh, maybe it doesn't fit on that. So there's a problem. Hardware controller, like, you really, really, really have to understand that. Go forward one slide, please. Yep. So the hardware controller, really, you have to put most of your energy into figuring out what is the hardware pattern that I'm going to deploy with. And yes, congratulations, now you're in layer 1, and you really need to figure out layer 1. And there are just so many edge controllers out there that you could play with, but they all have their quirks, they all have their problems. Maybe it's this Raspberry Pi 5, but you got the wrong board, or like the board itself doesn't really work for you exactly right, or am I gonna power it correctly? And oh, my least favorite thing, barrel connectors and power bricks and dongles. That's a difficulty. That's not going to go fix itself when it goes out and you left it 3,000 miles away from your engineering team. How are you going to kickstart this thing? How is it going to get re-imaged? One of the things that I've really focused on is thumb drives aren't super available globally, but where there are tourist destinations, you can always buy a micro SD card. So this is how you get started. You know, if you can put it on a micro SD card, and the other nice thing about this is that you can force it to fit a specific payload. You don't have this like multi-terabyte hard drive that you can play with. You can fit it on a micro SD card, and right now, kind of the threshold's about 512 gigs, which is a ton of data. So seriously, think about like, how do you refresh it? How does it get drop shipped to a location without having to get some pre-burn in? Because if you have thousands of these things, getting a pre-burn in contract so that you delay it gives you a supply chain problem. Whereas if I can just order one of these and it shows up from the like whatever DHL network or however UPS or that kind of deal, then that's super useful to me, because now I can hand one of these to a casual operator, somebody who is not a cloud expert, and have them bolted into this, execute 3 commands, and boom, we're back in business. And I don't have to send an engineering team out that is highly qualified to go chase bullets. Right? Who wants to chase bullets here? Not me. No, I'm a technologist first. Yes, I do work for the Air Force. However, you know, there's the tactical operation, then there's the cloud operation and edge controlling. Maybe the two aren't exactly the same overlap of skill sets. I'm good at this, maybe not so much running. Next slide.
All right. So another thing, we talked about the number of footprints and the explosion of copies. So one of the things that we thought about as we started our journey on the edge at Chick-fil-A back in about late 2016 actually is when we were starting to think about solving these problems and what sorts of approaches we would take. One of the things that we thought about was, if we have people ever making changes to these things that's not declarative and through some sort of standard pipeline, we are in trouble. There's so much potential for drift that can happen there. And so we kind of had this as a principle and a rule for us, which is if it's not declarative, it doesn't exist. I suppose it could exist if somebody broke the rules, but it shouldn't exist. And so this has been something that we've lived by. So when we started thinking about this problem, I'll tell you a couple of the things that we thought about. We wanted versioning, so like we should be able to see what versions of things are deployed to certain stores. We wanted to be able to roll back changes. Makes sense. We wanted to be able to clone and recreate a particular location's configuration if we wanted to wipe it out and recreate it. Actually a very common pattern at the edge to do that. We also wanted a well-known API. So does this sound familiar at all to anyone? Yeah, Git. So Git made a lot of sense for us as being kind of the backbone of this. And actually, come to find out, it's fairly simple to build and maintain a solution that has a bunch of Git repos and assigns something location specific to an agent that lives at the edge that pulls that stuff down with a Git pull that applies changes. We're in K3s in our environment, so applies Kubernetes manifest files and then closes the loop back via an API to let the cloud side of things, the control plane side, know this deployment was successful or it failed. Here's what happened. And so that's what we've been doing in our environment for about 6 or 7 years in production now. We were very early, so some of the cool projects like Argo, CD, and Flux were either not in existence or super early back then, and so we didn't know about them and actually didn't know that GitOps was even a thing or would be a thing. But this is the approach that we used, and it was super powerful for us. And one little nuance for us is you can see in the picture here, every location gets its own Git repo. That allows us to template things out across many repos and have kind of differences in configuration at each store over a time period, but ultimately everything can converge to kind of a global standard as all stores eventually get all of the same applications. So if it's not declarative, it doesn't exist. Super important if you're going to do anything at the edge at scale.
Security. At the edge at scale, you really need to understand, again, what is in this device. How are you going to secure it? How many secure slots do you have? Do you need to add an HSM? How much is the HSM going to actually cost you? How are you going to secure that to the device? Are you gluing that into the device? That way you have some sort of tamper awareness. Measured boot. Can I have a remote attestation of what's actually running on this device and whether or not we can remotely kill and wipe it, and how to do that signal without actually making that a vulnerability? Next slide.
Yeah, and you got to be really careful with the remote wipe thing and not create a bunch of remote bricks.
Oh, for sure. Yeah.
Super important. They're not
many
really
plane tickets for 3,000 miles away with barrel connectors and more SD cards.
Yeah, yeah, exactly. None of us want that feature. All right, so the next one, telemetry, but only when you need it. That sounds nice, right? So one of the things that's really important, and I'll tell you a quick story. When we first rolled out our Edge solution, I think we were only in less than 100 locations, but we actually had some impact on the business. But not the kind of impact that's good. It was actually the kind where we broke credit card processing for payments because we had applications that developers were putting at the edge that were consuming all of the available bandwidth for the store with their logs. So that was awesome. And so we learned from that lesson that there's some things that you need to design into your edge footprint that make sure that you only send telemetry out, you only send what you're truly going to use and what you really need, and you only do it when you need it. And this is where logging pipelines kind of came to the rescue for us. We use a tool that open source Vector, later acquired by Datadog, or the company that built it was acquired by Datadog, but great open source project. And the way it worked in our world is we would always send things like health signals from a store. We would also look for the absence of signals because if they're disconnected and we're not hearing anything from them, could be bad, so we might want to know about that. But we would look for health status and we would take major error logs back up to the cloud side so that that could make its way into dashboards or automation or things like that. But if something did happen and we did need more data to understand what went wrong, or maybe we just deployed an app and it's behaving weird, we built in a way to basically have a needs-based, hey, send me all the metrics, change the logging level for the next 30 minutes, very important, not forever because it'll stay that way forever. Change it for the next 30 minutes to be debug or info as well, and then auto switch it back at the end of that time period unless the development team that was deploying their app wanted to extend it for some reason. So these kinds of things become really important. And then what we did in our world is we have applications that live at the edge, but then we also have all these devices that live in our edge ecosystem around the restaurant, like fryers and grills and different things like that. And so we needed to be able to collect all the telemetry from all those things and kind of fan it in, make some decisions about what we're going to do based on the current logging config, shoot it up to the cloud when needed, and then basically fan it out because our edge is a platform for many different software engineering teams that build different applications. And so they may have their own preferences about what monitoring tools they use to troubleshoot their app, whether it's CloudWatch or Datadog or Grafana, Splunk, whatever it may be. So basically fan in on the edge, send out only what's needed, fan out when you get to the cloud to all the teams so that they have observability of the solution, but again, just enough. Michael, back to you.
Storage gremlins. Yeah, so your edge device, you really cannot rely on a single thing, right? So you really need to have multiple storage avenues inside of your edge device, whether that's multiple NVMEs, then how are you going to store it? Is it going to be block, object, and file? What does your apps dev team actually want? Do you need to deliver an entire, like everything in a box, 31 flavors of different kinds of storage? How are you going to deploy that? How is that going to be managed up to are you deploying Ceph? Okay, well, Ceph needs multiple OSDs in order to be reliable. So you really don't have that availability in your orchestrator, but you might have it in this giant box with 4 nodes and tons and tons of NVMe storage. So really figuring out how your storage mechanism works, what's your disaster recovery for that storage mechanism. I know it seems obvious, but it really isn't. What happens when things go wrong? Is this cattle, not pets? Do we just shoot it and get another one? Or is it that you absolutely want to have this operational data and that one piece of sensor that you really, 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 really needed that data from, do we have a way to get it back? And so having this Occam's razor sort of simple and elegant solution for storage is something you really deeply need to think about. Then are you going to actually back up? Are you going to pull the charts and or all the YAML files that you deployed to this thing? Because every edge is a little different. I know that every Chick-fil-A is exactly the same, but for us, we love to hold on to our old gear, so our edges are totally different in that we are trying to orchestrate more of a legacy operation that we need to drag along with us in these giant Pelican cases. So maybe that configuration needs to go back through the wire. How much are we paying for that back through the wire? It's something you deeply need to think about along with your fan out on logging. Exactly, Brian hit it perfectly in that we love our logs in the Air Force. Our logs completely consume things. So if you think about it, you need to push things back across the wire as minimal as possible, but yet still understand the operation at scale.
Yep. And by the way, keeping everything the same is what we call good architecture.
Ha, touche.
Really quick, speaking of, we don't have time to go deep into this, but just wanted to splash up a little simplified architecture diagram from Chick-fil-A. Shout out to all the people who contribute to open source projects. Like everything that we have done in our world is entirely built on open source technologies. Sometimes we were early and we had to hand roll our own, and now we're adopting the open source instead. But you can recognize a bunch of logos on here, things that maybe you've worked on or you've used. We certainly feel, Michael and I both do, that we
100%.
are standing on the shoulders of giants. And so we got to do something cool in how we applied these technologies in maybe a different way. But we're really grateful and appreciative of the community and all the things that are created that help us do what we need to do in our jobs. So really quick summary, do the differentiated heavy lifting, build your edge controller North Star. It's declarative or it doesn't exist. Security's got to be built in, not bolted on. Telemetry, but only when you need it. And then make sure to heed the storage gremlins and be ready for that fun. I want to say thank you, but also let you know that we have a Birds of a Feather session this afternoon if you want to talk more about any of these topics or dig into the architecture more. And hey, we have free t-shirts also. So love to see some of you guys. And again, thank you.
Thank you so much.